So you have seen that in polar coordinates, the equation for a circle gets a very simple form. Simply rho equals r, the radius of the circle. And this perfectly describes the circle. But what if I gave you other curves? So equation for other curves. And you should be able to use your intuition to describe these curves. For example, what if I told you the equation rho equals 1/2 of the cosine of 2 phi plus 1. This is an equation for a certain curve, okay? What does this curve represent? How can you figure it out? So I will walk you through it using an applet. So here in Mathematica, I have literally written down this function. So r, I call it r plot, is a function of phi, is 1 plus 1/2 cosine of 2 phi. And then I have this code that plots this, okay? And this is the result. So I have divided the screen into two parts. The actual curve in xy space is on the right, is this curve here, which looks like a peanut, yeah? So this is the curve that 1/2 cosine 2 phi plus 1 describes. But on the left-hand side, I have actually plotted, instead of doing the x and y axis, here on the left-hand side I have the phi and rho axis, okay? So in this left-hand side, the horizontal axis is no longer the x direction, but the actual angle. So if we move through the angle, if we move phi, we are changing the value of this horizontal axis, and this is changing rho, which is the vertical axis in this left drawing here, right? So for example, when phi equals pi halves, then 1/2 cosine of 2 times pi halves plus 1 is equal to 1/2. So that's why rho, which is the vertical axis, equals 1/2. And this can be translated onto the picture on the right, which shows that when the angle is equal to pi halves, that's why I'm showing this angle here, then the radius, the distance to the origin, is equal to 1/2. Now I increase the angle phi so that it's equal to pi. Okay, so I increase it to pi. So now we are here. So now the angle is equal to pi, and what's the radius equal to? Well, the equation is that rho equals 1/2 cosine 2 phi plus 1. So we substitute phi equals pi. Cosine of 2 pi is 1. So this is 1.5. So indeed you can see that the radius, which is the vertical axis here, is 1.5. Yeah. And that is also shown on the right hand side. So this time I'm going back to the xy axis. So now the angle, which is this angle, is pi, which is half a turn, 180 degrees. And the distance to the origin is exactly 1.5, which is why the point is here. So you can see that as we move phi, we are moving it in the between 0 and 2 pi, yeah, and this corresponds to different points along this peanut. Okay, so notice that the distance from the center first decreases, and that's why the peanut has a long distance, and then this distance starts decreasing. You can see that, yeah. Then it becomes minimum when phi equals pi over 2. Then the distance starts increasing again, so it's becoming longer and longer. You can see that rho is now becoming longer and longer until it is maximum when the angle is equal to pi, and then it starts decreasing until 3 pi over half, where it's a minimum again, and then it starts increasing back to 2 pi. So this describes this peanut shape, okay? So be ready, because in the live session I will ask you, using Poll Everywhere, this question. So I'm giving you here a curve in polar coordinates, 1 plus 1/5 sine of 5 phi, and you will have to tell me which of these 4 shapes it corresponds to. Okay, so you have to think how many maxima and minima you are expecting, and you have to tell me whether you expect a maximum when phi equals 0, or maybe it's not a maximum. So there are several tricks here that I will ask you in the live session. Now here I have another example of a very interesting curve, which is rho equals 1 plus sine of phi. Okay, this is a very interesting curve, and instead of asking you, I'm going to show you in the applet how this looks like. So let's do it. First, I need to modify my function. Instead of 1 plus that, I do 1 plus sine of phi. And I run this code. So this updates the plot. So this is called, this shape that we get here is called a cardioid. And it's called a cardioid because from the Latin is from the word origin of the word heart. Yeah. So it looks like a heart, although it's upside down here. So notice how to obtain this cardioid. So 1 plus sine phi looks like this if you plot it on the left with phi on the horizontal axis and rho on the vertical axis. So rho equals 1 plus sine. So you see a sine wave, but it's moved upwards by 1. So the sine wave goes between 0 and 2. Yeah. So notice that the sine wave starts when phi equals 0. 1 plus sine of 0 is equal to 1. So when we are on the x-axis, the angle phi is 0. The length of the distance to the origin is 1. Then as you increase the angle up to pi over 2, so that's what I'm doing now, I'm increasing the angle up to pi over 2, you can see that the distance to the origin is increasing progressively. Yeah. So this length is getting longer and longer, up to a maximum of 2, which corresponds to the angle when phi equals pi halves. Okay. So when this is a right angle, the distance to the origin is 2, which corresponds to this point here in the cardioid. Then we keep increasing phi, and this goes back to 1 when the angle is equal to pi, because sine of pi plus 1 is equal to 1, which means that when the angle is pi, it's 180 degrees, the distance to the origin is 1. And then as we continue increasing the angle phi up to 3 pi over 2, the sine of phi becomes minus 1, but since we are adding 1, the end result becomes 0. So now the radius, the distance to the origin, is 0. So you can see that indeed this distance vector here is getting smaller and smaller until it goes to 0 when the angle is 3 pi over 2. Okay? And then when we increase up to 2 pi, it increases to 1 again. So this is a cardioid. Okay? So if we go back to our whiteboard, we saw this peanut curve, but for example, if we plot 1 plus sine phi, this results in a cardioid. Which looks like that. Okay? So let me write it here. This is called a cardioid. Okay, so it's a skill to be able to figure out how different curves written in polar coordinates will look like. Okay? So thanks for watching and see you in the next video.